Billions of years ago, in the vastness of space, something incredible happened. Imagine a swirling, twirling dance of dust and gas. In the center, the sun burst into light, creating our solar system. Planets, moons, and other celestial objects emerged, each with its own special story. It's a cosmic phenomenon that still amazes us today. Stick with us till the end of this video while we explain in details the birth of solar system. The formation of our solar system is a fascinating and complex process that took place over billions of years. It is described by the Nebular Hypothesis, which is the most widely accepted model for explaining how our solar system came into existence. It all began with a nebular collapse. Approximately 4.6 billion years ago, a vast and diffuse cloud of gas and dust, known as the solar nebula, occupied space. While the precise trigger for its collapse remains a topic of ongoing study, it's believed that a nearby supernova explosion or a shock wave from a passing star may have initiated this process. As gravity took hold, the nebula began to collapse inward, compressing and heating as it did so. This inward motion set the stage for the birth of our solar system. As the solar nebula contracted under the inexorable pull of gravity, a remarkable transformation took place. The collapsing cloud of gas and dust not only shrank, but also began to spin. This movement caused the nebula to flatten into a rotating disk, a key evolutionary step in the formation of our solar system. At the heart of this spinning disk, something extraordinary occurred. Materials started to accumulate, drawn together by the relentless force of gravity. As this material amassed, it became denser and hotter, creating what we refer to as a protostar, a precursor to a full-fledged star. This protostar's core continued to gather more and more matter, intensifying the pressure and temperature within it. The pivotal moment came when the core of the protostar reached a critical point. The extreme conditions at its center, marked by soaring temperatures and crushing pressures, ignited a powerful nuclear fusion process. This process, known as nuclear fusion, transformed the protostar into a star, and that star is the radiant and life-sustaining center of our solar system, the Sun. Inside the vast protoplanetary disk, a delicate process of creation was underway. Within this swirling maelstrom of gas and dust, minuscule solid particles started their intricate interactions. At first, these particles were just tiny motes suspended in the cosmic swirl. However, over time, forces of attraction and bonding, such as electrostatic forces and van der Waals interactions, began to exert their influence. As these particles drifted through the disk, they encountered one another, and occasionally, they'd meet in a gentle embrace, sticking together through these mysterious forces. These occasional unions led to the formation of ever larger clumps of matter, known as planetesimals. As time marched on, the planetesimals in the protoplanetary disk didn't stand still. They kept moving, bumping into each other, and coming together in a kind of cosmic assembly line. These gatherings of planetesimals led to the formation of something bigger, protoplanets. Think of them as the early blueprints for future planets, like rough drafts that needed some more work. What made this whole process possible was the invisible force of gravity. Protoplanets, like magnets, started pulling in more and more material from their surroundings. The larger they grew, the more gravity they had, and the stronger they could pull in even more stuff. It was like a snowball rolling downhill, getting bigger and bigger as it collected more snow. Protoplanets, gradually growing larger and larger, were on their way to becoming full-fledged planets. They were the stepping stones in the grand construction project of our celestial neighborhood. In the inner precincts of our solar system, closer to the blazing sun, a remarkable transformation took place. Here, the prevailing conditions were marked by searing temperatures and a predominance of rugged, rocky, and metallic elements. It was in this fiery crucible that the terrestrial planets took shape: Mercury, Venus, Earth, and Mars. What distinguishes these planets is their composition and size. They are characterized by solid surfaces that offer a stable foundation, setting them apart from the immense gas giants located further out. Additionally, these terrestrial worlds are relatively modest in size compared to their gas-rich counterparts. In the chillier outskirts of our solar system, a different celestial narrative unfolded. Here, the prevailing temperatures dropped, and the cosmic elements at play were primarily hydrogen and helium, abundant in this remote realm. It was in these frigid conditions that the grand stage was set for the formation of gas giants, including giants like Jupiter and Saturn. What makes these planets unique is their composition. Unlike their solid-surface terrestrial counterparts closer to the Sun, gas giants are primarily made up of, well, gas. Their immense atmospheres consists of swirling gases and storms, with solid cores hidden deep beneath. As planets took shape and gradually increased in size, they played a pivotal role in a celestial cleaning operation. They effectively swept their orbits clear of smaller debris and wandering objects. This meticulous process not only ensured that planets had spacious, debris-free domains, but also contributed to the stability of their orbits. Moons around planets, including Earth's moon, formed through various processes, including gravitational capture of passing objects and giant impacts with protoplanets. Over millions of years, the solar system reached its current arrangement, with the Sun at the center, planets in their respective orbits, and smaller objects like asteroids and comets occupying other regions. Although the primary formation process is complete, the solar system continues to evolve. Collisions between objects, changes in planetary orbits, and the aging of the Sun all contribute to the ongoing dynamics of our solar system. The formation of our solar system is a remarkable story of cosmic evolution, and it serves as a model for understanding the creation of planetary systems around other stars in the universe. Well, that's all for today's video. If you liked it, please share and subscribe. We'll see you in the next video. Thanks for watching.